Today I encountered this question on lead code, largest divisible subset. So we are given an array of integers, so we have to find the largest subset. Basically in the question they have written subset, but they are actually asking for the subsequence. So we have to return the subsequence in which every two elements are divisible by each other. So for example, consider this array 1 2 3 4 5 6 10 12. So the longest subsequence in this array will be 1 2 4 12 and 1 6 3 6 1 6 3 8, because every element is divisible by itself, as 2 is divisible by 1, 4 is divisible by 2 and 1, and 12 is divisible by 4, 2 and 1. Similarly for this array also. So there are two ways to solve this question. First is using dynamic programming and other is using graph. So first I'll talk about the dynamic programming approach. So if we try to figure out that this question is very similar to the longest increasing subsequence, in which we are given an array and we have to find the longest subsequence in the array. For example, in this array the longest subsequence is 1 3 6 or 1 2 6. And to solve this question, to solve the longest increasing subsequence part, for example, our current index is at I, and suppose our current index is at 6 and we have processed till jth array. Then for dpi, which is the longest increasing subsequence till I, if the element at I is greater than the element at j, then we can say that the result till j, which will be whatever it will be, plus the current result which we are getting by calculating 3 and 6. So we are using the same logic to solve this question. For example, we are given 1 2 3 6 in the array, and for example, till this part we know the result that dp for these two will be 2, because 2 is divisible by 1. And if we are at this index and if we see that 6 is divisible by 2, yes, it is divisible. So what we'll do is dp of I will be dp of j plus 1. So by doing this we will get the result as the longest subsequence in which every pair is divisible by itself. But the question is asking the subsequence. We have to return the subsequence. So to do so, we'll take an extra array which we will call children, a child array of n. For example, at any point that we have got our result and we are performing this operation, so at this point we know that we have got a better result till ith element. So what we can do is we can say that 6 is divisible by 2, so the child of 6 is 2, but here we will be putting the index which is I and j. So the child of I will be j. So once we have filled this array, when we try to fill the child array, what we'll get is we know the child of this ith index, which is 0, 1, 2, 3. The child of 3 is 1. At 3 we don't have any result, so there will be -1. The child of 2 will be 1, which is at index 0. So we'll put index 0 here, and at 1 we don't have any child for that, so we'll put 1, -1. So when we try to return this subsequence of this question, so what we'll do is we run our for loop till the maximum length we have found, and we will push in that our result array the current child, which will be the latest index we have found, which is 4. So the array of I, and we have to go to the child of the index I. So the new index will be child of I, and child of I is 1. So at uh, new I will be index 1, and at index 1 we have 2. So like this we will full our result array as 1, 2 and 6. So this is the one way to solve this question, and another way is using graph. Uh, so for example, we currently have, so first we take this array as our example: 1, 2, 3, 4, 5, 6 and 12. So first we have 1, so we'll put 1 in our graph. Then we see that 2 is divisible by 1 or not. If it is divisible by 1, we will put 2 as the child of 1 and move on. Then we have 3. We see if 3 is divisible by 1 or not. If it is not divisible by 1, we will yes, it is divisible by 1, then we will put 3 as child of 1. If it would not be divisible by 1, we will put it as one of the neighbor of 1. But since 1 is divisible by all the elements, so we don't have to put it as a neighbor. So when we consider 4, so we'll see if 1 is divisible by 4 or not. Since it is divisible, we check the children of 1. We check the children of 1, which is 2. We'll see if 2 is divisible by 4 or not. Yes, it is divisible by 4. So we will put 4 here. Now we see if 4 is divisible by 3 or not. Since it is not divisible by 3, so we don't have to do anything for that. So let's move on. Now we have 5. So 5 is not divisible by any of the elements, so we will put 5 here. Now we have 6. 1 is divisible by 6, and we'll check the children of 1. Then we will check 2. 2 is 6 divides 2, so we will check its children, which is 4. Since 6 is 4 doesn't divide 6, then we will automatically put 6 as children of 2. Then we will check another children of 1, which is 3. Now since 6 is divisible by 3, we will put 6 as its child. So now comes 12 as the last element. Now 1 is divisible by 12, 2 is divisible by 12, and 4 is also divisible by 12. So we will put 12 here. Now we'll check children of neighbor of 4, that is children of 2. 6 is divisible by 12, and we will check there are no neighbors. We will check there another neighbor, so 5 is not divisible, so we don't have to do anything for that. Since we have formed our graph like this, now we just have to traverse this graph until the longest length we have achieved, which means that we have gone to the depth of the graph. And at this in this case, we'll start from 1 and check every node and check till the 12 the length we have got. In this case, there are two answers, which is 1 2 4 12, 1 2 6 12, or 1 3 6 12. So this was the logic behind this question. Hope you understand. Thanks for watching.